Here is another illustration on equivalent capacitance of symmetry circuits. Here you can see a network of capacitors is given over here, and we are required to find the equivalent capacitance of the circuit across terminals X and Y as shown in figure if each capacitor is of capacitance C. Now in this situation we solve it by using the potential distribution method, for which we connect a 100-volt battery across the circuit. And for this we consider on the right hand side the potential is 0 and on left hand side the potential is 100 volt. If we distribute the potential by symmetry, we can say at this point if potential is taken as X, here also it will be X. And by input output symmetry we can see here potential will be 100 minus X. Here also it will be 100 minus X. And if we further proceed at this point, if we take potential to be Y, then at this point potential should be 100 minus Y. And these are the midpoints of the circuit, so potentials can be taken as 50 and 50 because these 2 points are separated by identical circuit of capacitances on the potentials of 0 and 100 volts. So in this situation we can find out the value of X and Y to get the total charge flown through the battery. If we close down the switch here, the charge which is flown through the battery can be given as delta QF, and here the value of delta QF in either direction will be the sum of the charges of these three plates. So it will be, if capacitance is C, it is C multiplied by X plus CX plus CY. So here it can be written as 2CX plus CY. So we mainly need to calculate X and Y. So here if we write equation for X, you can see for X there are 4 capacitor plates connected, of which the sum of charge should be 0. So here we write it as CX plus charge on this plate will be CX minus Y plus charge on this plate will be CX minus 50 plus charge on this capacitor plate is C multiplied by X minus of 100 plus X. This should be equal to 0. Here the C gets cancelled out, and on simplifying we are getting 1, 2, 3, 4, 5X minus Y is equals to 150. That is here equation 1. Now if we write equation for Y, here you can see from this terminal Y there are 6 capacitors connected. So directly we can write the charge on these plates, like on this plate it is CY plus on this end this plate it is C multiplied by Y minus X. So I can write twice of C multiplied by Y minus X, plus on these two plates it is C multiplied by Y minus Y. So it is twice of C is Y minus 50. Plus on this plate it is C multiplied by Y minus 100 plus Y is equals to 0. Again C gets cancelled out, and on simplifying we can see it is Y plus 2Y 3Y plus 2Y 5Y plus 2Y 7Y minus this 2X is equals to, it is 100 and 100, 200. This here equation 2. I can directly solve these two linear equations into variables. I'll get the value of X and Y. Like here what I can do is can multiply 1 by 2 and add it in 2 multiplied by 5. So in this situation you can see this X will be eliminated, and what I'll be getting for Y is 2 plus 35. This minus 2 plus 35 is 33. Y is equals to, this will be 1300, and this gives us the value of Y, which is 1300 by 33 volt. And we can also substitute the value of Y over here to get the value of X, or we can also do this like 1 we multiply it by 7 and add it in 2. So here Y gets cancelled out and we are getting 33X is equals to 1250, which will result as the value of X as 1250 by 33 volt. And if we substitute X and Y over here, we get the value of charge flown through the battery using which we can find the equivalent capacitance across terminals X and Y, which is delta QF by 100. So this will be twice of C multiplied by X is 1250 by 33 plus the C multiplied by 1300 by 33 divided by 100. So in this situation, on simplifying, we are getting the result as 38 by 33C. That is the answer to this problem.